CPCTC Proofs. Let's do this. So, up until this video, you've been doing proofs where you always stop at this congruent triangle matches this congruent triangle over and over and over again. Well, that's gotten old. Let's spice it up a little bit. Now we're going to take it one step further, and after that, you'll have the ability to go sometimes 2 and 3 steps further. So, what is a CPCTC proof? Corresponding parts of congruent triangles are congruent was one of the first things you learned about what congruent triangles are. It means all congruent triangles have all 3 sides congruent and all 3 angles congruent. Everything matches up. So what we're going to do is use congruent triangles to prove that AB is congruent to DE in this diagram. It's taking it a step further. So, what we would normally do is finish with congruent triangles. But since we're not proving triangles congruent for our final step is AB is congruent to DE. Which means our triangles are going to need to be congruent the step before. Okay, so CPCTC proofs, you still have to prove triangles congruent and then go one more step. So we know the last 2 steps. As far as everything else goes, it's the same as it used to be. You could probably pause this video right now and go all the way up to step 5. And then step 6 will be 1 step more. So if you want to practice this proof, go ahead and pause it. Otherwise, let's go. Step 1, we give our given. C is the midpoint of both AE and BD. That was our given statement. As mentioned before, do not stop with a given until you've exhausted what you can figure out from it. We can figure out 2 things from this one given. We know that AC is going to be congruent to CE. We also know that BC is going to be congruent to CD. And we know that because midpoints cut segments in half or into 2 congruent segments. Well, this midpoint C is the midpoint of 2 different segments. So it's going to create 2 new sets of congruent segments. Okay, so the reason for both 2 and 3 would be midpoints cut segments into 2 congruent segments. Okay, so then of course AC is congruent to CE and BC is congruent to CD, and we have our diagram marked. And as I've mentioned before, if it helps you, you can say that these are sides and these are also sides. Remember, the order does not work in here all the time. So we're run out of givens. So that means we have to go to our picture proofs. What can we say directly from this picture? And we are going to look and see that we have vertical angles. So we have angle ACB is congruent to angle DCE because all vertical angles are congruent. Don't forget, you have to tell me that vertical angles are congruent. You can't just say vertical angles. You're not telling me anything about vertical angles. Got to be specific. So now you have enough to prove triangle. Be careful with the letters. Pick the first one. Triangle ABC just sounds like the logical choice. So then we have to remember to go in order for the next triangle. A is going to match up with E. So this would be EDC. Look at the pattern over here. Again, I mentioned that these are angles, so you can write them over here, but SSA is not our method. Over here we have a side, an angle, and a side, so this is by side, angle, side. Okay, so we proved the triangles congruent. That is all old school, right up to there. We just have one new step. Once you've proven that the triangles are congruent, we know everything is going to be congruent. A is congruent to E, angle B is congruent to angle D, and AB is congruent to DE, and that reason that all of those are congruent is because of corresponding parts of congruent triangles are congruent, also known as CPCTC. So that's it. Proofs as you've known them have just grown by one step. You still have to prove triangles congruent before you can use CPCTC. So if you're proving triangles are congruent, your last step will have SAS, SSS, ASA, AAS, or HL. But if you're proving sides or angles congruent, you still have to do that, but then your very next step is going to be CPCTC. All right? So that's it for your notes. It's just one additional step. If you would like, we have one additional problem for you to practice. You can do it in a 2-column proof. You can do it in a flow proof. You can do it in a paragraph proof. It does not matter how you want to do this proof. Just give it a try and see if you can prove angle A congruent to angle E, knowing that C is the midpoint of BD, and angle B and angle D are both right angles. Pause the video, give it a try. Let's see what you can do. So, does yours look a little bit like mine? If you did a flow proof, yours might. If you did a 2-column proof, yours might be a little different. Doesn't matter. We're going to get through it the same way. C is the midpoint of BD is going to tell us that BC is congruent to CD, and that is going to be our first set of congruent sides leading up to our triangles being congruent. The second given is going to tell you that they're right angles, and we know that they have to be congruent because all right angles are congruent, and now we have a set of angles leading into our congruent triangles. And finally, we have our given vertical angles from the very beginning. As I've mentioned before, if you want to do vertical angles or reflexive property type of proofs before you do the givens, that's fine too. At the very beginning, we see vertical angles, so we know that these are also angles leading into our 3 congruent parts for triangles. If you look at the order of the picture, this is the angle side angle pattern. So these triangles are congruent by angle side angle, and then we get to take it one step further and say that angle A is congruent to angle E by CPCTC. So if you did that in a paragraph form or in a 2-column form, if you have a very similar order, you are good to go. So that's it for CPCTC proofs. This is Longo and I'm out. See you, bye.